Hey guys, Justine here from Compass Maths Tutoring. So this week's tip is surrounding the topic of integration. And really we're just going to be looking at integration in its most basic form. However, what I find very common among students to trip up on is when integrating something like ax plus b to the power of n. So the rule states when integrating a function like this, you must add 1 to the power, divide by the new index, and then multiply that by the coefficient of x, as this rule states. So the tip I want to give you in this week's video is to show you the difference between this question here and this question here, although they may look very similar. So with this first example over here, we have 3x plus 4 in brackets or to the power of 2. So if you look inside, we're going to use this formula here, which states that the integral of ax plus b to the power of n is given by ax plus b to the power of n plus 1. So we add 1 to the power, and then we divide by the new power and multiply that by the coefficient of x, which is a. So the reason we can apply this rule to this specific example is because we see in the brackets exists 3x plus 4, and that is a linear function essentially. So 3x plus 4 satisfies this requirement, and therefore we can use it for this question. So I'm going to do as follows. So the integral of 3x plus 4 to the power of 2, you simply add 1 to the power. So what's in the bracket remains. So I'm going to add 1 to 2, which is 3, and I'm going to divide by the new power of 3, and then multiply that by the coefficient of x, and the coefficient of x is 3. And I'm going to plus c because it's an indefinite integral. And then just simplifying that, I'm just going to simplify the bottom. And we get 9, because 3 times 3 is 9, plus c. So if we look at this example here, how does this question differ from this question? And if you look closely inside the brackets, this says 3x squared as opposed to the 3x over here. So when a lot of students see this, they automatically assume that you can use this formula right up here. But I'm going to explain to you why you cannot. And the reason is because the expression that exists in the brackets is not a linear expression. This has a power of 2, which is a quadratic expression, and therefore this formula does not hold true for this question. So instead, what we must do is expand this and then integrate each one separately. So what a lot of students tend to do is realize that, since it's in brackets and it's got a power, you simply just follow through the same steps as we did in this question. But that's not true. You need to understand that what's in the brackets needs to be a linear expression. Otherwise, the only way to do this is through expansion. So as follows. So expanding this, we're just going to use the normal binomial expansion. So the binomial expansion, I'm just going to write it up here. It's a plus b squared. So you square the first term, plus you double the multiplication of these two terms. So it's 2ab, and then you square the last term. So I'm going to do the same thing here. So it's the integral. So I'm going to square the first one. So we get 9x to the 4. I'm going to multiply these together and then double them. So 3x squared times 4 is 12x squared. Double that is 24x squared. And then I'm going to square the last term, which is 16. Now that we've expanded it, we can integrate each one of these separately. So we follow through with the normal integration process. So we add 1 to the power. So 4 plus 1 is 5. So this becomes 9x to the 5, and we divide by the new power. We do the same thing here. So we have 24x to the power of 3 over 3 plus 16x, and then we plus c. And I'm just going to simplify this expression because 24 over 3 is 8. So we get 8x cubed plus 16x plus c. So the main thing I want you to carry away from this video is that when you have something like this to integrate, before you apply this formula over here, you need to ensure that the expression that exists in the brackets is linear. If the highest power is not 1, then you cannot apply this rule. So what you'd have to do instead is expand it and then follow through with the normal integration process. I hope that helps.